last section of the entire topic 1. We are finally finishing up topic 1, which means next week you should expect a really small quiz because it's only over these 2 sections. Right before fall break, just in time. But notice that we are combining 1, 6, and 7. That's because we are taking out the stuff that you need to do by hand. We're going to focus on doing it with technology. That's why you'll notice in my notes I have skipped example 1 and we are ready to dive into example 2. Example 2 is going to look a little messy. I do want a graph over here. So I'm going to draw myself a graph first before moving on to Desmos. Okay, so the really nice thing about Desmos is that you do not have to get y by itself. So if you remember using calculators when we were in school, we always had to get y by itself in order to be able to graph it. Well, that is not the case with Desmos. So it's going to look like this. You may want to pay attention to where all the colors are overlapping on top of one another. That can make it a little more difficult to see. So there's some programming and code type stuff that you can do to make this look much cleaner. But for, I'm not really super worried that you can write code in Desmos. So, honestly, the easiest way to make this happen is what we wanted to see is where all the colors overlap each other. So like the black was all this part. The red is lower, so that means at the moment the intersection is like that trapezoid shape. Still the trapezoid shape. Still the trapezoid shape, but it's hard to tell with colors. So what you can do instead is go through and change them all to the same color. So like if I change them all to blue, I know that the overlap is the darkest blue. So meaning we have an intersection here and here. So 0, 0, 7, 0, 0, 5, and 6, 2. And so those are the points that I am going to graph. The points around the darkest spot there. So what was that again? That was 0, 0, 0, 5, 1, 2, 3, 4, 5. So maybe I'm labeling them here in case you did not get them. 7, 0. And then last but not least, 6, 2. And this is the only part of shading that I am considering the solution set. So the solution set is when it all overlaps. The solution set is the overlap of all the colors. And like I said, with Desmos, I still believe that the easiest way to do that is to change them all to the same color and see where the darkest is. The darkest is going to tell you where all that overlap is, and it's easier to see that way. All right, so next up, we are still in 1-6, but we are jumping down to example 4. So notice we're going to write a system of equations with a matrix. So what in the world does that mean? A matrix is just an array of rows and columns. So an example of a matrix could be something as simple as this, where you pick numbers and put them in there. So in this case, there are 2 rows and 2 columns. So we would say that its dimensions are 2 by 2. So how is that going to help us? Well, that's because in Algebra 1, you may remember doing something called the elimination method or the addition method to solve a system. And it required a lot of math. You had to multiply, you had to simplify, cancel out, all kinds of things. But doing it via a matrix is going to make your life easier. Okay, so when something says write a matrix for the system of equations, you're going to put all the coefficients. So like this is the x column, this is the y column, and this is the constant column. So what do I mean? So we're talking about coefficients. So the coefficients in front of x are 3 and -2. Okay. The constants in front of y are -1 and 7. So be very careful. Anytime there's a minus sign there, that does make it negative. And then proper terminology says that we put a line there to associate that we are augmenting this matrix, and our constant is 4 and 20. Right? In our next video, we're going to learn what we're going to do with that, because we will actually do something with it. But for now, just know that that's how you write it. So what if I wanted to go the other way? So like I'm given the matrix, what does my system of equations look like? Well, again, we go in order. This time x, y. I've got an extra column here. The last column's always the constant. So that means that the third column is z. If you like ABC better than x, y, z, that's okay. Envision will usually tell you what to put it in terms of. So like it'll say in terms of x, y, and z, or in terms of a, b, and c. All right, so here we do 0x plus 2y plus 3z equals 4. Repeat, 8x minus 1y. Remember, we don't actually have to have that 1 there because 1 times y is just y. Minus 2z equals 5. And then last, 2x plus 0y plus z. So again, 1z is just z, equals 9. Now, some of you are like, you corrected 1. Why are we putting 0? Remember, 0 times any number is just 0, so we don't actually have to have it. We can take that part out. That is okay. So if we wanted to pull this 2x closer and like put it right here, we can. But this is the system of equations for the matrix that is given. So again, we will be using this information in our next example, but first to see if you can figure out what it's like to write a matrix for the system. So we have now switched over to 1-7, where we're actually using a calculator to find answers instead of doing it the hard way like we did in Algebra 1. So we are, let's see, what page is this in your workbook? I put it at the top. So we have flipped over to page 52 in your workbook if you are following along. Again, this is another plug. If you haven't picked up your workbook from school, I highly recommend it. All right, so when it says what is the solution to this, it says each, but I only did A. So let's just work on A. First thing I'm going to do is make a matrix like we did in our previous example. And my numbers are going to be 2, -5, 11, 4, 3, and 9. If you would like, you may put your line there. However, when we put it in our calculator, we don't always have that line there. So just know that for calculator purposes, we may not have that line. All right. And the next thing I want you to do is go to www.desmos.com/matrix. Even if you have been doing Desmos from an app, I personally have not found Matrix as an app. So even on my iPad here, I have to open up Safari, which is the desmos.com/matrix website. So you'll see this. And we're going to do a new matrix. We need to edit how many rows by column it is. So if I go back here, I have 2 rows. I have 1, 2, 3 columns. So 2 rows, 3 columns. Hey, now I have the amount that I did in my example. Looking at my example, I do not remember my number, so sorry, I'm going to have to flip back again. 2, -5, 11. So 2, -5, 11. One more time, 4, 3, 9. Okay, so notice that that's saved as A. Okay, so see A. We are going to use RREF. It stands for Row Reduced Echelon Form. That's a whole lot of fancy things. There's a long way that your calculator takes to solve it. I, in fact, took an entire semester worth of math to learn how to do it by hand. Lucky you, you get to use Desmos to do it instead. So first you click RREF, then I put A to state that I want the matrix above to go in there. And notice at the end here, it gives me 103, 0, 1, -1. That's important. So let me make sure that's right. I'm already doubting what I had. 3, -1. See, that's why I checked my work. All right, so change that to 3, -1. So this is basically our final answer. We just have to understand what it means. Our answers are always found in the last column, and they go in order. So this is X, and this is Y. So this system, meaning that they cross paths when X equals 3 and Y equals -1. If you write that as a point, you could also write that as 3, -1. And that is the answer for the first problem. So the next problem is just like it. So I'm actually going to keep it in the same video so that we can do this together. But you will notice, so if I think about this being X, Y, Z, and the constant, my first row is fine. It's 1X, 1Y, 1Z, and the constant is 13. In the second row, there is no X, so I'm going to use 0 where X is. So 0, 1, -1, so tricky because that's a minus sign, 3. And then, icing on the cake here, the third row is not in order, so I do have to remember a little bit of algebra skills and move that over. Remember when you move it to the other side of an equal sign, it changes signs. So this becomes -2x plus z equals, there's nothing left there, so the number to denote nothing is 0. So I have -2 for x. Notice I have nothing for y, like there's nothing there. So 0 for y, 1z, and it equals 0. Now I have a problem that looks exactly like the problem before it, except a little larger, but that's okay. So what that means is when I go over to Desmos to type this in, I can actually go back up here and just change A as it is. So this was 1, 1, 1, 13. I got smart and wrote this down elsewhere so that you don't have to get dizzy watching me go back and forth. So 0, 1, negative 1, 3. And then negative 2, 0, 1, 0. All right. So the nice part about this is it is still keeping my RREF A. So, but it changed it accordingly. So now my answer is 2, 7, and 4. Okay. Remember, your answer is always the last column after these are turned into what's called our identity matrix, where ones go down the diagonal. Our last column is the answer. So x equals 2, y equals 7, z equals 4. It is possible to write that as points 2, 7, and 4. All right, so now you try it, and then we will do last example. We are in 1-7, example 5. It's our favorite word problems. I know that sometimes we find them difficult, but if we break them down, hopefully they are not as difficult to us, okay? So, a student has $128 in a savings account. If she were to withdraw the money and was only given 1s, 5s, and $20 bills, how many bills of each denomination would she have? Assume that she has a total of 28 bills and she has 3 times as many $1 bills as she does $5 bills. Okay, so let's let X be $1 bills. Let's let Y be $5 bills. And let's let Z be $20 bills. I don't know what their problem is with $10 bills, but there are none of those in this example. Okay, so the student has $128 total. And we know that she has some amount of $1 bills. So 1 times however many $1 bills she has will give her the monetary value of that, right? Whereas 5 times however many $5 bills she has will give her the number, or give her how much money she has. So for instance, if she has 3 $5 bills, 3 times 5 is $15. Okay. And last, 20 times however many $20 bills she has. So if she has 3 $20 bills, she has 20, 40, $60 worth of $20 bills. Now we know that how many bills she has altogether is 28. So X plus Y plus Z equals 28. So like if she has 5 $1 bills and 4 $5 bills, and then 17 $20 bills, which that is not correct because that is way too much money, but that's what I'm talking about in summing there. And then the last piece of information, which I think is the hardest, she has 3 times as many $1 bills as she does $5 bills. This means that $1 bills is 3 times the $5 bills. So what does that look like as a system? Well, there's no Z whatsoever, so I know that's 0Z. But I need to move this over, so it's going to become X minus 3Y. It has nothing left, so the constant is 0. I have 1X and then minus 3Y. So what will that matrix look like when I do the matrix? I'm going to write it out first. So 1, 5, 20, 128, 1, 1, 128, 1, negative 3, 0, 0. So this is the matrix. I am going to type in my calculator. This would be a great point for spot for you to pause and try typing this in the calculator yourself to see if you can get the correct answer and interpret, and then press play again to see if you got it right. All right, so I typed all that in. I now have 18, 6, and 4 as my final answer here. So it looks like this in my calculator. So let's interpret that to our real world problem. So 18 is X, 6 is Y, Z is 4. That means she has 18 $1 bills. She has 6 $5 bills. And she has 4 $20 bills. Okay, so does that add up to 28? It sure does, 18 plus 10. Is that $128? So 4 times 20 is 80, 6 times 5 is 30, 18 times 1 is 18. Add those together. Sure enough, you do get 128. Does she have 3 times as many $1 bills as $6 bills? Yes, 18 is 3 times as much as 6. So all of this fits without having to play the guess and check until it's right game. So there's your real world example. Last video of the unit. Make sure to finish your target, and then you will